Hello everyone. Today we're looking at how the apophum of a polygon can be used to find the area of a regular polygon. Now this term apophon is a little new, we haven't used it before, but in a regular polygon, that's a polygon that has equilateral and equal angular components, the apophum is going to be the segment drawn from the center of the polygon perpendicular to the opposite side of said polygon, such that in the figure here, AP is the apophum, while AR is the radius of this circumscribed circle, basically the circle that goes outside of a regular polygon. Don't worry, we're not drawing circles today. Now, we can use this apophum, this segment here, to essentially help us solve for the area of a regular polygon, using the equation that the full area of the polygon is going to be equal to 1/2 the apophum times the perimeter. So this area is equal to 1/2 of the apophum times the perimeter of the figure. To review, regular polygon means the polygon is equilateral, all sides are congruent, and equal angular, all angles are congruent. The radius of a regular polygon, that simply means the segment joining the center of the polygon, in this case A, out to the vertex of an angle. The apophum is going to be the segment joining the polygon center to the midpoint of a side, also known as a perpendicular bisector if we form a little triangle here. Triangle ARS. AP would be the apophum and the perpendicular bisector of triangle ARS. Now, how do we use this to find the area of a regular polygon? Well, first things first, we're going to need to find the central angle of our miniature triangles. The central angle is determined by looking at 360 degrees, which is essentially the number of degrees around any point in space, dividing that 360 by the number of sides in the polygon to give us the central angle measurement, in this case the measurement of DOC. We'll divide that central angle in half to give us the angle between one of the radiuses and the apophum. We'll then have to use that angle and possibly that radius or a side to find the length of the apophum. And this means we're going to be using some form of trigonometry. As you may recall, this is our SOHCAHTOA. The sine of an angle is equal to the opposite divided by the hypotenuse. The cosine of an angle is equal to the adjacent divided by the hypotenuse. And the tangent of an angle is equal to the opposite divided by the adjacent sides. Once we have our apophum, we find the perimeter of the regular polygon, and then use the formula above, reproduced here, that the area, let's make that a little smaller, such that the area of the polygon is equal to 1/2 the apophum times the perimeter. And that'll give us the area of said polygon. So, let's take a look at a example problem. Find the area of the regular hexagon with a radius of 6 millimeters. So right off the bat, we have a radius of 6 millimeters. So if the center is there-ish, then from the center out to a vertex is going to be 6 millimeters. Now we've made a little isosceles triangle for ourselves. Now this angle, this central angle, is going to be equal to 360 divided by 1, 2, 3, 4, 5, 6. So 360 divided by 6 gives us a central angle of 60 degrees. we're now going to draw in our apophthegm here in purple. Our apophthegm is going to run from the center of the polygon down to the opposite side and form a 90-degree angle. As it's also going to perpendicularly bisect the opposite side, and in this case, it will also cut up our central angle, making the new angle here in orange 30 degrees bisected. Because we know this angle here is 30, this angle is 90, therefore this angle must be 60 degrees. Making this a 30, 60, 90 triangle. And we can use our special right triangle properties to determine that our apophthegm, our purple line, is going to be equal to half the hypotenuse times the square root of 3. And if you need review on special right triangles, contact me and I'll send you some review material. So the apophthegm is 3 times the square root of 3. Our perimeter is going to be 1, 2, 3, 4, 5, 6 sides. Each side here is going to be 6 millimeters as well. So 6 times 6 equals 36. So our area of our polygon, let's put that in brown, area of the polygon is equal to 1/2 times the apophthegm of 3 square root of 3 times the perimeter of 36, which, if you multiply all that out, will give us 54 times the square root of 3 millimeters squared as our answer. It doesn't tell us to round anything, so we're going to leave it as a square root of 3. If it did tell us to round things, we would multiply out that square root of 3 and round appropriately. Now, real quick before I continue, some of you might have been confused as to why I jumped from saying, well, this was 6 millimeters, making this 6 millimeters as well. If you recall, in a 30, 60, 90 triangle, the hypotenuse is twice the length of the short side. So this short side here, which I'll put in green, this short side here would have been 3 units in length. Our apophthegm is a perpendicular bisector, so it cut up this full side into 2 equal parts. So if this part is 3, that makes this part also 3, which makes this side 6. There are 6 sides. 6 times 6 gave us our 36. In case you were confused as to where that 6 came from. So now let's take a look at some guided exercise problems. We're going to find the area of each regular polygon and round our answers to the nearest tenth. So, number 1. The equation for our area is 1/2 times the apophthegm times the times the perimeter. We have a side, and we have a 1, 2, 3, 4, 5, 6-sided figure. Therefore, our perimeter must be 60 centimeters. So perimeter equals 60 centimeters. My apophthegm is given to us as 5 times the square root of 3. Therefore, this becomes a plug and chug operation of A is equal to 1/2 times 5 square root of 3 times 60. Multiply all that together and then round to the nearest tenth. We should get our area is equal to 259.8 centimeters squared. Number 2, similar principle. Our equation is that the area is equal to 1/2 times the apophyum times the perimeter. We have a 1, 2, 3, 4, 5-sided figure, with each side having a measurement of 10.9 meters. 10.9 times 5 gives us a perimeter of 54.5 meters. Our apophyum is given to us at 7.5 meters. Therefore, this becomes a plug-and-chug equation such that the area is equal to 1/2 times 7.5 times 54.5. Rounding to the nearest tenth will give us an area of 204.4 meters squared. All right, last problem. We want to find the area of a regular pentagon with a side length of 8 inches. You'll notice that the only thing we know about this off the bat is that the side is going to be 8 inches in length. Everything else we're going to have to find on our own. So, first things first. Our central angle, put our center about there. We're going to draw out our little triangles. Triangle there, triangle completed. And we're going to have our apophyum, put that in blue, there. I know my apophyum essentially acts as a perpendicular bisector. So I've got a right angle there, and this side is bisected, so each of these sides here, each of these parts, is 4 inches in length, because the full thing is 8 inches in length. So I'm going to go ahead and put in those that 4 real quick. I now need to find what this angle here is going to be. To find that, I need to figure out what my central angle is. And my central angle is going to be 360 divided by the number of sides I have. So 360 divided by 5, which gives me 72. Therefore, if the full angle here is 72, that means this angle here, half of that, is going to be 36 degrees. So now, I have an angle, I have an opposite side, and I want to find the apophyum, which also happens to be the side adjacent to my 36-degree angle. So I'm going to call my apophyum, I'm going to call that just A, as it stands for both the apophyum and my adjacent side. To find my A value, I'm going to use my trigonometry rules. Specifically, I have an angle, I have a opposite side, and I'm looking for the adjacent side. Well, that's basically going to be TOA. So my equation to find my apophyum will start off as the tangent of 36 is equal to the opposite side of 4 divided by my unknown value of A. I'll multiply both sides by A. That'll give me A times the tangent of 36 equals 4. Divide both sides by the tangent of 36. So A is equal to the tangent. A is equal to 4 divided by the tangent of 36, which will give us approximately 5.5 as our apophyum. If we take it out a few more decimal places, it's 5.505, etc. But since we're rounding, I'm going to round to the nearest tenth to keep things nice and clean. So now I have my apophyum at 5.5, and my perimeter, meanwhile, is going to be 8 times the number of sides I have. 1, 2, 3, 4, 5. It is, after all, a pentagon. So 5 times 8 is 40. I now have enough to plug things into my area equation, such that my area is equal to 1/2 my apothem of 5.5 times my perimeter of 40, which will give me an area of 110 inches squared. And that's all the notes. If you have questions, as always, please email me.